Okay, so if we take a look at this question here, we roll a die 5 times. What's the probability they ask us about the 5 rolls in terms of sixes? Well, we don't want to draw a tree diagram with 5 sets of branches, one for each roll. It's just going to be too complicated. It's going to take too much time. I'm going to show you how to do this a bit more efficiently. So for the A part, it says what's the probability that we roll all 5s? Again, you don't need a tree diagram for this, but I'm going to draw a partial tree diagram. So we're talking about our first roll. We can either roll a 6 or not a 6. Oops. 6 or not a 6, and we know that the probability of a 6 is 1 over 6. Not 6 is 5 over 6. Again, if you look at the A part, we only care about rolling all 6s. So we only care about this part over here. Again, our probabilities are rolling a 6 and not a 6. And we know that's 1 over 6. Again, we want to have all 6s, so we only care about the upper pathway. I'm going to keep extending that for each of our rolls. And you're only going to care about the upper pathway because you want to have all 5 6s. Okay, so if we look at this, if we roll all 5 6s, we know we have to take this upper pathway here. So our probability of all 6s is just going to be 1 over 6 times 1 over 6. Again, make sure you calculate the exact value in your calculator here. Don't round any of these numbers till you get your final solution. You get a probability of rolling all 5 6s. Very, very small probability. Okay, for the B part, it's basically the same concept, but instead of going the entire top way, you're thinking about not rolling 6s each time. So you're thinking about just the bottom pathways for each one. Now the probability of each of those bottom pathways is 5 over 6. Basically a probability of no 6s is going to equal to when we want to do the C part, probability that we roll at least 1 6. Well, again, we don't want to draw a tree diagram for all of this because it's going to be too complex. To solve the C part here, anytime you have an at least question, you can also use the complement rule. So probability of at least 1 6 is going to equal to 1 minus the probability of rolling no 6s. We know that the probability of no 6s we calculated in the previous part to be 0.402. we are going to get 0.598.